Okay, so check it out. We're dealing with motion here. With motion, we have position, velocity, and acceleration. This is very, very much heavily relied on in physics. So if you've taken physics prior, that's great. Or if you plan to take physics, this will be a good foundation. Position, S of t, is typically done in feet as far as units. And then the change in position, the derivative of position is going to be velocity, which would be feet per second. And a change of velocity is going to be acceleration, which is the derivative of velocity or the second derivative of position. And that'd be feet per second squared. So you have basically feet, feet per second, and feet per second squared are the standard units unless otherwise noted. Now, within that, you're going to get certain topics. So velocity topics might be not moving or at rest, and that's when you set the velocity equal to 0. That's when the object is not moving or it's at rest for a moment. Moving in a positive directions when the velocity is greater than 0, moving in negative directions when the velocity is less than 0. Then for acceleration topics, these are tricky because speeding up and slowing down isn't just acceleration, it's the combination of velocity and acceleration. Speeding up is when velocity and acceleration have the same sign. So if velocity is positive and acceleration is positive, you're moving forward and accelerating forward, you're speeding up. If velocity and acceleration are both negative, that means you're moving backwards and accelerating backwards, you're speeding up in the backwards direction. If velocity and acceleration are opposite signs, like positive, negative, or negative, positive, they're going against each other, you would be slowing down. So do be careful about that. And then last topic here, displacement is just position final minus position initial. Where was I finally? Where was I initially? What is the displacement? Distance, you have to first find where the velocity is 0, and then find the absolute value of the intervals the velocity is the same sign, okay? What I mean here overall is, let's say you had 0 to 5. This is a velocity number line. Let's say you're moving forwards, backwards, and forwards. And you were asked a question of something along the lines of, like, find, let's say, the velocity from, not the velocity, but find the distance from t equals 1 to t equals 8, something like that. So, okay, to go from 1 to 8, well, I can't just go from 1 to 8 because I moved forwards, then backwards, then forwards. So what I would have to do is I'd have to find the change in position. So from 1 to 2 seconds, so that's s of 1 minus s of 2, and I'm taking the absolute value there. Then I would add it to the distance traveled from 2 to 5 seconds because that was in a different direction, so that'd be s of 2 minus s of 5. Then I would go from 5 to 8 seconds because that's where it's split up again to go in the positive direction, s of 5 minus s of 8. Make that all the way across. Come on, there you go. And by the way, I know you might look at this and going, wait, shouldn't I do s of 2 minus s of 1? Well, the order doesn't matter because you're taking the absolute value. Basically, from 1 to 2 seconds, you're going in one direction. You want that distance traveled. From 2 to 5 seconds, you're going another direction. You want that distance traveled. And then from 5 to 8 seconds, you're finding in the positive direction that distance traveled, and you're adding all those positive distances together. Could be 0 as well if you weren't moving in the first place. So let's actually give it some more context, okay? Given a particle moves according to an equation here, s of t equals t cubed minus 3t squared plus 10. Let's first find the velocity and acceleration equations and the number lines. So let's see. So the derivative of position is velocity. That'd be 3t squared minus 6t. Set it equal to 0, you get 3t, t minus 2 equal to 0. And I would set up a number line with 0 and 2 seconds on there. That's my velocity number line. From there, I could plug in numbers before and after into the derivative here, like 1 and a 3. And the factor form is great. If I plug in a 3, I'll get 3 times 3 is 9. 3 minus 2 is 1. 9 times 1 is positive. And then if I plug in a 1, I'll get a positive times a negative is negative, which means I'm moving backwards from 0 to 2 seconds and forwards from 2 seconds onward. Then the acceleration equation, I take the derivative of the derivative, 6t minus 6, set that equal to 0, and I get t equals 1 second. So I draw a number line again. I include 0 because we're assuming time is positive here. We're moving forward. So from 0 to 1 seconds, we're going to go ahead and plug in a number before and after, like maybe 1/2 and 2. Plug a 1/2 in to the acceleration equation. Half of 6 is 3, minus 6 is negative. Plug in a 2 and it's positive, and that's my acceleration number line. So I can say quite a few things here. I can give you the intervals where acceleration is negative or positive. I can give you the intervals where you're moving backwards for velocity and moving forward for velocity. For speeding up versus slowing down, it might be useful if you drew the velocity and acceleration equations on top of each other and make sure it goes in order 0, 1, 2. That way you can see when the signs are the same, when the signs are different. Because you can see that we are speeding up when the signs are the same. That means from 0 to 1 second, both velocity and acceleration are negative. And then after 2 seconds, you can see that they're both positive. It's slowing down when they're opposite signs between 1 and 2 seconds. And that's how you can compare there. Lastly, distance versus displacement. For displacement, you just do s of 4 minus s of 1. So I don't even take derivatives here. I just go up to the top equation on screen. I plug in a 4 for t. I would get 4q, which is 64, minus 48 is 16, plus 10 is 26. Plug in a 1 at the very top. 1 minus 3 is negative 2, plus 10 is going to give you 8. And 26 minus 8 will give you 18. And we're assuming standard units of feet. For distance, though, you had to know first where the velocity was equal to 0, which we already found. This occurred over here. So it looks like it splits up at 2, which means I'm going to have to find how far it traveled from s of 1 to s of 2. And then I'll find out how far it traveled from s of 2 to s of 4. Because from 1 to 2 seconds, it went in the negative direction. From 2 to 4 seconds, it went in the positive direction. So s of 1, we already found was equal to 8. Plug a 2 into the original equation here. So let's see, that'll be 8 minus 12 is negative 4. Negative 4 plus 10 is going to give you 6. We just found s2 was 6. We found s of 4 earlier is 26. So we end up getting 2 plus 20, which will be 22 feet. That's how you find displacement and distance. Before that, speeding up and slowing down. Before that, the position, velocity, and acceleration equations, how they relate, and their number lines.